Well, stack is a container, or one of the containers that you can use. In fact, it would be extremely difficult to program without any kind of container. I think a while ago we've seen a vector as being dynamic array of objects. Today, let's consider a stack. Basically, stack is a container which behaves like this. For instance, if I say integer my array and create an array of 5 numbers and initialize this array of 5 numbers with something like 11, 22, 33, 44, and 55. Altogether 5 integers. Very simple, right? So I have this block of memory, and there I have my values 11, 22, 33, 44, and 55. All of them are integers, and they're stored in some place. So you know from quizzes already that the actual name my array contains the address of the first integer, right? So that's I can almost like draw it like 3D, that because they physically take all this space, and I have allocated them. Now, when I create the stack, I said integers, I'm sorry, I said std, standard library namespace, stack of integers, which is using those angle brackets, int, right? And I said st, and then I said a semicolon. What this creates, this basically creates an object which can be populated dynamically. So I have some object here, which is the stack, right? So some object in memory exists which represents the stack. And what I can do with the stack, and I can say stack push, right? Push 7, right? Push 7. What it's going to do is that it magically is going to maintain internally maintain like a container like this, with like an open end at the top. So this number 7 is going to be placed there at the bottom. Okay? If then I say stack push, for instance, instead of hard-coded 7, something like my array index 1, right? This my array index 1, of course, refers to this is index 0, this is index 1, this is index 2, this is index 3, and 4. These are all indices that I can legally access inside my array. So basically, my array 1 refers to this number 22 in memory, because that's the element of the array which stores 22. So that will essentially extract 22, and 22 will be placed on the stack. And now the content of my stack is 7 and 22. Okay? Then an interesting part of the stack is that it restricts access to the elements that are placed on the stack only to the top element, right? It's like a stack of plate in the in the restaurant. You go and you can pick the the buffet. You can pick the top plate of the stack, and it's usually like a springboard that pushes it up. And so the next person will get the next plate, and the next person will get the next plate. And plates are usually the same kind, right? You typically have a certain size of that stack of plates at the buffet, and you go there, and everybody gets the same size. Another stack will have a different size of plates, and that will be a different stack. So that's why we specify that this is a stack of integers. Some other stack could be a stack of characters, for example, or a stack of some other things. And your access is restricted only to the top element of this stack. So basically, if I have populated my stack with some values, then this is the only thing I can access, this element right there. To access it, I can say std cout, and I can display the value, right? I'm just trying to use these angle brackets here. Display the value at the top of the stack. You simply say stack.top, right? Top is a function, member function inside the stack which provides you access to the top element. So let's demonstrate this in the code. So we're going to do the similar thing as we did. For instance, we can say integer my array of 5 integers, which equals initialized 11, 22, 33, 44, and 55, something like that. Then I can say stack.push, and that pushes the number, and I can say, you know, my array, let's like push everything on the stack. To push everything, I will say index 0. Okay, and then I can say index 0, index 1, 2, and 3, and 4. In this way, I'm using my array to populate my stack with the values 11, 22, 33, 44, 55, 55 being the one on top, right? So if I wanted to see it, I would say stdcout display, we can say top of stack is, and we can then say display st, which is the name of our stack, top, right? So the top part of the member function provides access to the top of the stack, and we can display a new line there and see how this works, right? So we can basically try to observe how this works. So I'll just say build it, and run it, control F5. It says top of stack is 55. Let me do my usual adjustments. I wonder why it doesn't remember my adjustments. I do this all the time and it doesn't remember it. So I'll just keep modifying, I guess. Let's go to something we can recognize, whatever, the colors, and so there, right? So top of stack is 55. Okay, all right. So then instead of just hard-coded values like this, what I could do is that maybe I could say something like int array size equals 5, right? And use array size instead of the hard-coded number here. I really don't like hard-coded numbers, so this would be the right direction. And you already should know that in order to specify the size of your locally created array with specific number of integers, there is this horrendous restrictions that this number has to be a constant. In other words, this number has to be known to the compiler at compile time. So that's the restriction. But anyway, I will use my array size. So this time, instead of pushing all of this, I will push something using a loop and using an index, like IDX is my popular variable name. And I will do this in a loop, right? So I can say for this index starting with 0, and index is less than the size of my array, less than this array size, right? And then plus plus index. So I loop through all the indices that I can legally access, and inside this loop now I can populate my, and of course I need to specify that this is just an integer, right? So here I can do this in a loop instead of hard-coded lines like I had before, and if I build this I should get exactly the same result. It should say that top of the stack is 55.